right? Did anyone not understand this? How to write an equation, or write a point or a pair? Okay, how many of you had trouble with the next one? The answer is -6.3. Anyone need that explained? You do? Okay, it says,
Oh, yeah, never mind.
never mind.
Yeah, never mind.
Does anyone need it explained? Okay. How about for 5? 4.2 is the answer. Okay, how about number 7? Do you guys know what a scatter plot is? It's just a graph with dots. These are ordered pairs, but they want you to use 0 for the year 2000. So you would use a 1 for 2001. On your y-axis, you have sales. Here is one possible answer for this. I know it's really hard to read. That's what a scatter plot looks like. It's just a bunch of dots. And what people do is they look at these, the dots and how they are related to each other, and they say, okay, the year, if they look like they're clustered close together and they're going up, they say those two items, the X and the Y, are positively correlated. As the years go up, the sales is going up. So they make conjectures about the relationship between the two. Okay, how about number 9? Number 9, it says estimate the average price in 1987. We have to read this problem very carefully and know that in the year, if you read this, the year 1985 is 0. So this is the year 1986, 87. Well, they want to know what is the average price in 1987. So you're going to look here, and I would read that as about 95 cents. And then they want to know for 1995, it's about $1.19. Okay, the next thing they're asking you is what's the average, the percent increase from the year 1987 to 1995? Well, how do you do that? What you do is you have to figure out the two prices on those 2 years and subtract them. And then you divide by the first. They want to know from 87 to 95, that's the first. So this price is 95 cents. So it's the difference of them, and even no matter what, take the bigger number and subtract the smaller number. You don't want a negative number here. So it's $1.20 minus 95 over 95, and you get turn it into a percent. Now, why is it an increase? Because from 87 to 95 it went up, so it's a 26.3% increase. And then in what year was the average price at least $1.10? You would look on the y-axis where you would find $1.10, where that would be, and you would figure out it's this right here, and then all these years. So I would say from 1989 to 1996, and from 1985 to 1986. Questions? Next. In 11, in what quadrant? It's 4, and in what quadrant? 3 and 4. For 13, they ask you to plot these points in this one, and then they're telling you to change the sign of all the y values and then plot them. How could you relate these points? Well, you go from A to B to A to negative, the opposite of B. So if you change the y values to the opposite, what you should notice is that each point is a reflection over the x-axis. And that's something that we're going to talk about later in this class. When you change the y value to the opposite, it's a reflection over the x-axis. If you were to change the x value, it's a reflection over the y. For 15, yes, it is a function. You look at the x values, they're not repeating. But 17 is not because -5 is repeating. Yeah? Good? Okay, 25. Did we do that last graph? Did we run out of time? I can't remember in this class. We did it? Okay. How do you do the domain for this one? Then you should have been able to do this one. The domain goes from -3 to 3, and it's including those two with no breaks. So we're going to use brackets at the ends of -3 and 3, versus the range, it's going to be, again, brackets at -4. The range is the y value. This thing goes from -4, you always want your smaller number on the left side. And it goes from -4 all the way up to 3. I get really frustrated when if I see an answer like this. What's wrong with that? And every year I see that on a test. What is wrong with 3? Do you go from 3 to -3? No, that is incorrect. Same with if you were to reverse those. So in something like that on a test, I'd give you partial credit. For 29, they want you to state the output. The output is the y value. If I give you these inputs, so at -2, you get a -1. At 0, 3, at 1, 2, 2.5, -1, and -1.50. And the last question, can you evaluate a function? If I give you g of -2, what are they telling you to do? They want you to put -2 into this function, so where you see x, put a -2 here and evaluate it. You should get, I got this answer, or if you used a calculator, I got -0.59. So I would take either answer. This is called an exact answer. That's an exact answer. This is an estimated answer. This is a decimal that goes on and on. What kind of a number is this? This is an irrational number. For letter B, you should have gotten 0. C is another irrational number. You should have gotten about 0.83 or root 8 minus 2. Or you could have written root 2 root 2 minus 2. Here's another answer for this one. 2 root 2 minus 2. That's another one. For letter D, it's 1, and for letter E, it's 2. Does anyone have any questions on these? No? Okay. Today what we're doing is review of linear equations. You guys remember linear equations? What is a linear equation? What does a linear equation look like? Everybody says y equals mx plus b. When you have two variables, when you're comparing two variables, and we usually say x and y, and both x and y are a degree of 1, who's missing one? So when you have two variables, so you're going to compare two quantities, x and y, A or B. If you're comparing two quantities, here's your first quantity, call it x. Here's your second quantity, call it y. When you're comparing them, you're finding relationships between these two. If both the x and the y are have a first degree to them, so their powers are 1, and we don't write the ones, we just understand. This is a linear equation. So, what we could do if you had an equation like this, x plus y equals 2, you could make a t-chart, and you could say, okay, what would x have to be If x were 0, what would this have to be so you add them up and get 2? 2. What if I said 1? 1. What if I said if x is 3? What would that have to be? What would it be? Negative 1, right? Okay, so if I plotted these points, 0, 2, 1, 1, 3, negative 1, and if I were to connect these dots, what kind of a relationship do they form? They form a linear relationship. All these dots are called solutions. These are ordered pairs. These are solutions to the equation or the graph. This is the graph, this is the equation, and this is the table. You are going to be able to go from a table to a graph to an equation, a graph to an equation to a table. Any way I give it to you, you should be able to go from one to the other. These are all saying the same thing. Okay? They're all functions. So you could write f of x. We're going to talk about the characteristics of this linear relationship. And the first thing we're going to talk about is the rate of change from one point to the other. Does anyone remember what it's called? How you go from one point to the other? It's called the slope. The slope measures the rate of change from one point to the other. You remember it as the rate of the change of y over the change of x. That's called the slope. Okay? Some lines have a positive slope and some lines have a negative slope. We always read a graph from left to right. So, here's the left side. Here's your line. If you read a graph left to right, if your graph is rising as you go to the right, this has a positive slope. So when you figure out the relationship from one point to the other, it's the change in y over the change in x. It's going to be a positive ratio. Your slope is a ratio. It's the change in the y value. It's the difference, this difference over the difference of the x. X is in the denominator. For some reason, people always make the mistake, they think because x is first, they put x in the numerator. Now, what if your line is going this way? This is a negative slope line, right? So it's positive if you're going up, it's negative if you're going down. So think of going up the stairs or down the stairs. Okay, so now, look at this first example here. If I gave you two ordered pairs and I said, okay, we have 0, negative 1, so let's graph, where is 0, negative 1? There it is. And where is 4, 1? 4, 1 is right here. If we were to connect these two, that's our line. I want to know what is the rate of change. How did I go from one point to the other? First of all, is it a positive slope or a negative?
Positive.
It's positive, okay? So what I want to do is figure out how to get from here to here. I went up 2 units and over 2. So I went up 2 and over 4. Well, if slope is the difference of the y's, and the difference, how many units do you have here? 2, over the change in x, that's a 4. What is my slope?
1/2.
It's 1/2. What does that mean? To go from one point to the next, I went up 1 and over 2. Now, how do you do this mathematically, not on a graph? Well, do you guys remember in algebra, did you ever learn the slide? Okay. Remember this, the slide? Anyone learn it? Okay, here's the slide. Look what did I just do? What did I just do?
First one over the second one.
I just put one point over the next. Now what am I gonna do? I'm gonna draw a slide. That's a slide, right? Now why do you think I did that? Because right here, I'm gonna keep these y values on top. Now, why did I write -1 minus 1? Because the definition of slope, it's the difference, this is the difference of the two y values. And now, what do you think I'm gonna slide these down here over 0 minus 4. Now, let's do the math. What is -1 minus 1? -2. What's 0 minus 4? And simplify it, you get 1/2. So if you have to do it algebraically, that's what you do. Okay? All right, flip. Oh, uh-oh. These copied wrong.
Yes.
You know what? Most of you guys have it right. The two people that got the new copies, yours is wrong. It's Matt, and what is your name? I'm sorry.
Ian.
You have the wrong copies,
Yeah.
but that's okay. Because I'll give you, what am I gonna give you? I can't give you this because I need an original.
Just not do it.
Can you just listen? And I'll have to get you a good one. Look what it did, it copied the wrong page. Uh-oh. Okay, I'll hook you guys up. I will hook you up. Okay, but the rest of you guys, we're having copy machine problems. We get these new copy machines, and if the machine runs out of staples, it's not working properly. And we're struggling with getting them, the staples in. No one knows how to do it, and so we have to call service. So anyways, we're all using the one upstairs because it's the one that has staples. Oh well. Okay, look at this back page. You two don't have this back page. You two don't have this back page. Okay, but just pay attention and you'll be fine. All right, look at these two lines. Does anyone recall what form, and I already heard the word, but
Slope intercept.
slope-intercept form. What does slope-intercept form mean? What does it mean? You guys say it. If an equation is solved for y, if y is by itself, the number in front of x is the slope, and the number after is called the y-intercept. So if I were to take this and graph it, A, what would I do? How do I graph that? Where do I begin?
0, 3,
You begin at 3, you guys know this,
0,
and you go what? Up 2 and over 1. Why did I go that way? Why didn't I go the other way?
3. There's a negative.
Because it's a negative slope line, right? So that's that first equation right there graphed, and this is all old stuff. How do you graph the next one? You start at 3, and this one you're going to go up 1 and 2 this way. Well, looking at these two lines, which would you say is steeper? If you were skiing down this slope, this line, or skiing actually coming this way, which is steeper?
A.
A, this is steeper. So how do you know what is a steeper line? I don't care about the negative. The negative doesn't matter. What direction the line's going, the line that has the bigger number is steeper. So 2 is bigger than 1/2, ignoring, so in other words, take the absolute value, and the bigger number is the steeper, okay? So, everybody knows how to graph an equation in slope-intercept form, which I gave you that right there. So, how do you do 4? How will you graph this if you have an x and a y, and it's not in slope-intercept form? What should you do?
Put it in the slope.
Get y by itself, so tell me what to do.
Move the 5x over to the other side.
Bring this over, and what do you get?
2, 1.
Okay, am I ready to graph it?
No.
Am I?
I did that
Gotta get
backwards.
through.
Okay, so just do that, like that.
The whole thing.
The whole thing.
Oh, the whole thing. So how come you guys don't do that? Just wondering.
We do.
You do? Sometimes. Not all the time. Okay, where do I go now? What do I do? I'm gonna begin at
1,
1, and I'm gonna go up 5 and 2 to the right. Now, should I continue that pattern? That 5 to 2, 5 to 2? Yes, if you can, do it. Easy stuff, right? Okay, another easy concept. Another form that we should remember is point slope form, the easiest form. If you have a point and a slope, this is called point slope form. So if I say, write the equation of a line that passes through 2, 1 with a slope of 3, all you do is put your 2 in here, it goes into the second x1, y1, and your 3 here, and you're done. So this would be y minus 1 equals 3 times x minus 2, right? Now, what if they say, write it in slope-intercept form? What are you gonna do now?
Get the 1 on the other side.
Distribute the 3 first and then add 1, yes, okay. So, how do you do example 6? I'm gonna give you the point 1's -6 and the slope of 2. I want you to do 2 things for me. I want you to graph it, and I want you to write the equation in slope-intercept form. So those 2 things you're gonna do for me. So can you first start off with writing this in point slope form? What would you write? Y minus 1?
Y minus y1 equals m.
Y minus what? Wait.
Y minus 9.
Y minus, I'm hearing different answers.
Y1.
Y,
Y1.
okay, Y, okay, you're giving me the equation.
That's already there though.
Okay, well, that's all right. Is that what you're giving me?
Sure, yes.
Okay, then what? I'll start there.
Plug in -6.
Plug in what?
-6.
Like that?
No,
Plus
Oh,
six.
good job. A -6 is a +6, okay? Just wanna make sure you're paying attention. All right, now, what's this answer? It's an equation, but did I answer the question? No. The question is, write the equation in slope-intercept form. If I ask you, what's your favorite color? What color do you like?
Yellow.
And you say, pizza, I love pizza. Did you answer my question?
No.
So when you guys give me that for an answer, that's as crazy as to us as asking you what's your favorite color and you say pizza. Okay, you're not answering my question. And I can't give you credit. I can't say, oh, it's right, because then you think that that's slope-intercept form. No, this is math language. Math language says, okay, slope-intercept form looks like what? What does it look like? It looks like, yeah, that's the answer. Okay? So I'm warning you, in this class, this is pre-calc, watch what they ask you for. Answer your question. I can't say, oh, I really like you, and I'm just gonna mark it right, because I think I know what you're talking about. If it's not answered correctly, it's not right. Okay? So watch it. So how would you graph this? Well, you could do one of a few things. You could actually plot 1, -6. If you did 1, -6, and then went up 2 over 1, you do your graph. Or, and if you extended this, you would see that it's gonna hit at -8. So either way, however you wanna do it, it's fine with me. Okay, now,
Thank you.
gentlemen, you have the next page on your, you have this page, here, right? You have this one. We have a couple special lines. Couple linear relationships where they don't have 2 variables. What do you do in example 7 when you only see a y and you don't see an x? with a number, what kind of a line does it look like? It's a horizontal line. When you see y is 3, and if you can't remember, what you could do is you could say, make a little T-chart. Sometimes we forget. No matter what, y is 3. So you could plot a couple points, 3 points, and connect the dots. And you will see that it is a horizontal line. Now, here's a question for you. What is the slope of all horizontal lines?
0.
0. Very good. 0 is the slope. The slope is 0. But the equation is like the name of it. The name of this line is y equals 3. Well, what about if it's a vertical line? What's this equation right here? If I asked you to tell me what's the equation of this line, what is it? X equals 2. Now, if I ask you the question, what's the slope of that line, what would you say?
Undefined.
It's undefined. Good. So you remember all the differences of these special kinds of lines, undefined slope. Okay? We're almost done, guys. Okay, here we go. 2 special kinds of lines. If I take 2 lines, and I want these 2 lines to be parallel, what characteristic do you know about those 2 lines? If they're parallel, what do you know about them? They never touch. Their slopes are the same, and their y-intercepts are different, right? Their slopes are the same. What about if they're perpendicular? What do you know about them? What's their, do you know, remember the relationship about their slopes? Opposite reciprocal. Okay, so now, question for you. I'm going to give you an equation of a line. Here it is. It's 3x minus 2y plus 6 equals 0. I want you to write an equation of a line that has this 2, -1 in it, but one that's parallel to that and one that's perpendicular to that line. So what should we do first? What do we need? We need the slope-intercept form of that line because we want the slope. We want the slope of this line. How can we quickly figure out the slope of this line? Instead of subtracting 3x, instead of subtracting 6,
Send the 2y to the other
send the 2y, yeah, I like that. So, you're in pre-calc, whoops, that's a y. Think about moving y. You don't have to have y on the left side all the time. It's much easier to bring -2y over than it is to bring these 2. Are we ready?
Let's go.
Are we ready? No, we have to first get rid of the 2. And I really don't care about the y-intercept, but just to, you know, what the heck, let's just finish it. So here's this equation of this line. What important information do we need? We need this slope. Okay, so now, let's go back and read the question. They want an equation of a line that's parallel to that line. And it passes through 2, -1. Does it say what form to write it? Does it say, I want it in this form? If they don't ask you for a particular form, take the easiest route. What's the easiest route? If we know the point and we know the slope, what's the easiest route? Point slope. Yep, point slope. So how would you do A? This is point, I'm going to write it for you. Here's point slope. So all we need to do is put a 3/2 for m. And what's the point? It's 2, -1. So y plus 1, x minus 2. Done. If they would have said, write the equation in slope-intercept form, then we have to get rid of the 3/2 and distribute and all that other fun stuff. But they didn't say it. How would we write this answer perpendicular now to this line? The only thing that's going to change is what? And it becomes -2/3. Do you remember this stuff? Is it coming back? Good. All right. The last form that you need to remember is this form, ax plus by equals c. It's still a line, but it's a formal line. We like this form I'll tell you what this form is good for. See if you recall. If I gave you, this is an easy one. That's called standard form. When an equation is written like that, it's standard form. If I asked you to graph this, you'd probably want to get x, y by itself. I have an easier way. Or maybe it's not easier. But if I do this, do you know what I'm doing? What am I doing?
Finding y and x.
I'm finding out the x and y intercept. You know how easy it is? Watch. If I do this, looks like, reminds me of tic-tac-toe. If I put a 0 in for x, watch. It's really like just pretending like that doesn't exist. What's y then? Solve that in your head. 0, 3. Where's 0, 3? It's right here. And then what if I put a 0 in for y? What's that? 4. Where's 4, 0? Right here. There, I just graphed it. Easy. It's x. That's the nice thing about standard form. But sometimes they ask you, take an equation and write it in, put it in standard form. I like to think a standard form is a formal equation. There's no fractions, and there's x's in front and then y. It's kind of like you're going to homecoming. Would you wear what you have on right now to homecoming or prom?
Actually.
No, it's just a differently dressed equation, okay? That's all it is. It's the same thing, it's just you in a suit, okay? So, what's wrong with this? It's in slope-intercept form. Standard form says no fractions, just like when we say prom, no flip-flops, even though we kind of do, girls, because our feet hurt. It's like no jeans, okay? How do you get rid of that 1/2? What's the first thing you're gonna do? I'd multiply everything by 2. Multiply everything by 2. A 2, a 2, and a 2. You get 2y equals 1x. See these cancel out? Plus 6. Next, what's wrong with this equation? You want to bring the x way in front. Way in front. When you bring this way in front, all you're going to do is change the sign. Okay, now, this is good. Is there a better answer? Why is this a better answer? You don't want to start off a sentence with a negative, if possible. Get rid of it. How do you do that? You divide everything by, or multiply everything by -1. Change all the signs. I would accept either one of those answers though. I'll take it. But just so you know, one is better than the other. I am done teaching, and the rest of this stuff is homework. Do your best. And for those of you that did not get the homework, if your packet's it's not right. What's missing? You're missing one page,
Second,
right?
take the back page.
Second one.
Okay, let me. How much time do I have? Oh, I might be able to do it on the computer.
Yeah, like 15 minutes.
I gotcha. Turn this off.